Speed. It's nice to have in a racing car, even a toy one, and it's nice to have if you're racing, trying to finish a job on your personal computer. Now, with all the talk of 20, 25, 33 megahertz speeds and 386, 486, even 586 chips, what are the real benefits of computer speed in terms of performance? And what is the value of those benefits in terms of the cost? We'll get answers today as we take a look at the quest for computer speed, Megahertz Mania, on this edition of the Computer Chronicles.
The Computer Chronicles is made possible in part by the Software Publishers Association, which reminds you that software piracy is a federal offense. When a few people steal software, everyone loses. Additional funding is provided by CompuServe, by PC Connection and Mac Connection, by Byte Magazine and Bix, the Byte Information Exchange, and by Intel Corporation, Personal Computer Enhancement.
Welcome to the Computer Chronicles. I'm Stewart Cheifet. With me this week is Jan Lewis. Jan, we're talking about computer speed. I have a little demo set up here, a golf game on an XT clone and on a 33 megahertz 386 AST over here. Now, let's see the difference in speed as we repaint the scene, this particular game. On 3, hit R, okay? 1, 2, 3, go. Yours is done. And mine is just beginning to do this. You see the difference? Now, this is a trivial example maybe, but from a typical user's point of view, why should I care whether I have a 33 megahertz chip or a 16 megahertz chip?
Yeah, by the way, let me also point out that this is running in CGA mode. This is in VGA mode. Had this been made to run in VGA mode, it would have been even slower.
And it's still not done.
It's still not done. I'm on my 5th hole already, probably. But the point is, the main reason that an average user is going to know they need more speed is because they're running an application with graphics such as this. They're doing desktop publishing, multimedia, something like that, and it's just too slow, and you know you need more speed.
Yeah.
Second reason is that you're doing things like spreadsheets, word processing, whatever, and you simply know that your spreadsheets are getting big, they're slowing down, you simply want a linear extrapolation of what you're doing now, you want faster, and that's all. And the third reason is that as we get more into software that has artificial intelligence and voice recognition and things of that nature, we're going to find these applications that simply won't even run because they're too slow. So it's those reasons.
Jan, today we'll take a look at some of the real performance benefits of speed on your computer, and we'll show you ways how to speed up your computer without having to go out and buy a new one. Now, most of us are happy running our 286 or 386 machines, and then Intel comes along and says there's now a 486 chip, and coming soon a 586 chip. Where will it all end? We begin with a report from the chip makers, Motorola and Intel.
Computer speed may be a luxury when you're crunching a spreadsheet, but it's a matter of life and death during a medical emergency. The quick response of a computer, providing a doctor with instant information, can save a patient's life. Computer speed begins with a microprocessor, but speed is a function of two elements, the architecture of the chip itself and the clock speed of your system, usually rated in megahertz. Everyone wants more speed, but there are limits and trade-offs.
The ultimate speed in the design is taken the way Motorola's done it, is we've done a number of trade-offs. I mean, you can use faster transistors, but that increases power dissipation. At the same time, you have to balance the rest of the semiconductor technology that builds the computer product. And you don't want a fast microprocessor that just waits for memory to finally give it the information it needs. So we try to balance it off and hit the power targets and the overall system performance targets of the user.
Improvements in computer speed are driven both by technology and by the market. Software companies continue to develop applications that demand more speed, and chip makers continue to solve the problems of performance bottlenecks that lead to faster processing. While there are limits to computer speed, at companies like Intel, they keep on trying to surpass those limits.
We still have a long way to go in the speeds of our microprocessors. Today we're at 33 megahertz is the maximum speed of a microprocessor that Intel manufactures. 10 years from now, we expect to be shipping microprocessors that operate at speeds up in the range of 200 megahertz. We still see another factor of 6x in clock frequency that's possible in the upcoming decade.
For the Computer Chronicles, I'm Maria Gabriel.
Joining us in the studio now is Larry Fortmuller, Director of Marketing with AST Research. Next to Larry, Neil Rubenking, contributing editor with PC Magazine. Jan?
Neil, we hear so many different elements that go into the speed. We hear about the different processors themselves, the different speeds of the processors, the caching, things like that. How do all these interrelate, and what do you use for what? What's the best thing to use?
Well, the best thing to use completely depends on the thing you want to do. If you're using a big database program, the data's on the disk and it has to be read constantly, so you get a fast disk and you add caching. If you're doing a graphics-intensive programming, you get a graphics coprocessor, and no matter what you're doing, if you get a faster processor, the computer will run faster, and each of these benefits adds to the other. So if you do everything possible, you can increase the speed of your computer just to an amazing level.
So it's more than just a question of megahertz, or more than a question of what chips in the machine.
It's more than megahertz.
All right, speaking of megahertz, that's the one part we want to focus on of the many Neil just talked about. And tell us what your setup here is, Larry.
Certainly, Stuart. What we have here is 3 different computers, each at a different speed. AST's Premium 386SX, over on the left, runs at 16 megahertz.
Okay.
In the center, we have a full-blown 386 chip running at 25 megahertz, and then on the far right, a 33 megahertz machine. And we've got some software that we thought we could run to show the viewers a little bit about the relative speeds and the effect that the relative speeds of each of these processors have on the performance in a real-world application. In this case, the first case here, we have an example of a graphics program and how some pretty active graphics is affected by the megahertz rating of the machine.
Let's run through this.
Okay, Jan, if you'll help out. Ready, set, go. What you can see happening here is that the 3 machines will actually operate at different speeds, and although we started at the same time, they'll quickly get out of sync because of the relative speeds of the 3 machines.
And obviously the one on the right running at 33 megahertz is now running way ahead.
You got it.
The middle guy at 25 a second, and the slowpoke here at 16 megahertz.
And they're getting more out of sync.
Is dragging along.
Right.
And as you were saying at the beginning of the program, Jen, then graphics is obviously one heavy demand in terms of speed.
Yeah.
All right, now you have an Excel demo also you talked about, in which we can see a more typical number crunching speed race, if you will. Could we get out of the graphics bit here and move into the Excel demo?
We can do that, Jan, by hitting escape. And we'll enter the number 2 this time.
Okay.
And we can start that pretty much at any time, Jan, and it'll come to a break point and we'll get them all started at the same time.
All right, tell us what's happening as we watch this.
Okay, you know, there's lots of ways to benchmark machines, and there's no real right answer. You've got to look at the applications that you use in the real world in order to decide how you're going to measure your machine and make a common sense selection. If you're a number cruncher, if you're into Excel or Lotus 1, 2, 3, or any other numerically typical type application, then running this sort of a test will give you some indication as to what's right for you.
Do we have to hit enter here to get these guys going?
Yes, we sure do. We can do that at any time, Jan. Okay. Now, each of these these programs will run separately. It'll iterate through some integer mathematics and then some floating point mathematics. When it gets done, it will time itself, and it'll give us a numerical indication of how fast each machine performed the test.
Okay, now, is that one finished already?
Probably. Yes, it's finished the first half, and now it's gone into the floating point version.
Okay, so again, all 3 machines are doing the same task, doing this big crunching job on an Excel spreadsheet. When it's all done, it'll report to us how long it took each machine to do it.
That's exactly right.
While we're waiting, let me ask you, you have a 486, the Mystic 486 chip here. Tell me about this board and how it relates to your AST machine.
Sure. The folks at Intel have done some more magic with the 486 chip, and that's, of course, the latest in their cadre of chips. Each of the 3 machines here are part of the AST Premium series, and each of them has an architecture we call Cupid 32. Cupid 32 is a way in which we've been able to separate, if you will, the processor components of the machine such that we can upgrade any of these models to a higher megahertz version. In other words, the SX can move to a 386-25 or indeed to a 33, and now, of course, to the 486 chip. And it's a simple upgrade. You simply unplug one board, pop in another, and fire up.
All right, taking a look at our demo here, old 16 megahertz is just barely finished up finally. Now, can you show us some graphic representation of the difference in performance speed?
Yes, I believe I can. We've graphed the results here, and that'll come up in a second on the screen to your far right. And what you'll see here is that there is a curve. In red, we see the integer results, and these machines, by the way, don't have a math coprocessor in them, and therefore we're seeing relatively slow floating point results, but still the ratio is the important thing here. And we can see that as we move from a 16 megahertz that takes a relatively long period of time, we move to the 33 megahertz, things get done at a much faster clip.
Anyhow, isolating on megahertz and speed of the chip, we really see a difference here.
Right.
Thanks a lot, Larry. Neil, you're going to be back in just a minute. If you can't afford to buy some new powerful 33 megahertz machine, there are other ways to get more performance out of your computer. We have a report.
Silicon Valley's Tech Mart was recently host to the first computer show devoted entirely to computers powered by Intel's 386 microprocessor. The 386 was a big leap forward for personal computer users, both in terms of speed and features.
I think there's a true quantum step from 286 to 386, not just performance, but capabilities, things that the 386 can do. The 386 was designed to be a true multitasking microprocessor. The difficulty in getting reliable machines at high clock speeds, for example 33 megahertz, is a hardware challenge. It's just a matter of getting components that can operate at that type of speed to design a system that utilizes those components correctly.
Vendors at the 386 Power Expo offered an abundance of ways to boost your PC's performance, from plug-in boards to entire systems. But many computer users may not realize that there are ways to fine-tune existing systems without making heavy investments. Disk caching software, for example, shifts hard disk information to the system memory, speeding up data access. Shadow RAM is another way to increase speed by moving system-level software from the ROM or read-only memory to the faster RAM or random access memory of your computer. It can result in dramatically improved video performance. These solutions are inexpensive and quick, but they may not suffice for users who need intensive calculating power.
I think it definitely should be done from an application perspective. The easiest example to think of would be people doing computer-aided design. In that case, oftentimes you're waiting for the computer to do a very large redraw of a figure or remove hidden lines, that type of thing. Those people are going to get a very dramatic improvement if they go from a 286 to a 386 or from a 386 to a faster 386.
For the Computer Chronicles, I'm Maria Gabriel.
With us in the studio now is Srini Nageshwar, president of Cumulus Corporation, and next to Srini we have Ken Operly, president of Hauppauge Computer Works. Jen.
Ken, what are the advantages of using a board to go for speed as opposed to a whole new computer?
Well, usually you end up preserving most of your investment. Monitors, disk drives, and all of the things that people buy that go with their computer are still very useful, still good equipment. And if all the computer needs is more speed, a new board will give you that.
Now, what are the trade-offs? In other words, I got to lose something by just going for a board rather than a new computer.
Well,
are there compatibility trade-offs? Are there risks involved?
Not really. Buying all a new computer would have is a newer motherboard in it and possibly newer peripherals. So if you're looking for the absolute latest in high-speed disks, fancy video, and if you're going to be upgrading all of those parts of your system anyway, well then buy a new one. But if you're satisfied with most of the parts of your system, except for its speed, a motherboard replacement is a good option.
Okay, Srini, Cumulus has an accelerator board, right, rather than a motherboard. And tell us about that and then show us what the effects are.
Okay. What this board does is we take this place of the 286 chip that is on the motherboard. We remove the 286 chip, and then we have a small board that contains a 387SX that plugs into the space where the 286 chip was. Sorry, and so you don't have to change your motherboard. You don't have to change any other parts of the system, and you get to have a 387SX machine for just the cost of the small board.
Okay, so this is an AT upgrade situation.
It's
now.
an
Okay,
AT.
show us what you've set up here, Srini.
What I have here are two identical IBM ATs, identical except for the fact that one of them contains one of our boards and the other one is the exact original AT. We have exactly the same program, AutoCAD, running on both of them, and I have the famous St. Paul's Cathedral picture. What I'm going to do is have both of the machines regenerate the same picture by starting them off at the same time.
Okay, so this is your typical CAD situation, which is a heavy user speed, and we see the difference already, don't we? What is the factor? Can you quantify that?
Yes, I think what you'll find is that this machine on the right will go through 3 loops of the same picture before the other one will complete its first one.
Okay, so about a 3-to-1 speed up here.
Actually, it'll be into its 3rd loop, so it's slightly more than a 2-to-1.
What are the cost factors here for viewers thinking about, well, instead of buying a new machine, I'll buy this accelerator card or I'll buy this board? What kind of price are we talking about?
Okay, the suggested list price of this kind of board is about $595, and what actually this board gives you is you don't need any other additional hardware investment except for this board. You get to keep everything that you got, and you get to run all the 387 specific applications.
386.
I'm sorry, the 386 specific applications that come out and that will be coming out. And what we've found is that in many Fortune 500 companies, people like to standardize on one set of applications and run them across 386.
Okay. And Ken, what about the price on your motherboard?
They start at $1395 and go up depending on amount of 32-bit memory installed and exact speed.
Okay, Jan was asking you to compare buying a computer to buying a motherboard. Now, what would be the benefit to your motherboard approach as opposed to Srini's cheaper accelerator card?
Okay, it's basically one of cost versus performance. The motherboards come in higher speed selections, and because they're based on real 386 32-bit processors instead of the 16-bit SX bus, they will be able to run 32-bit software, much of the newer software Srini talks about, even faster.
Ken, while we were talking behind the scenes, we swapped some hardware here. Now tell us what the configuration is now.
Okay, we took the AT that had Srini's accelerator card in it, lifted the I/O cards out, slid out the old motherboard, slid in a new motherboard, and put the same I/O cards back.
And could a typical user do that on his own without outside help?
Sure. A user who has replaced a RAM card or added an I/O or a modem card of some kind, it's the same level of difficulty.
Okay, so tell us what we have here and what's the demo?
Okay, we brought up AutoCAD again, put up a different picture for a little variety, and I'll ask Srini to hit the Enter key and compare an original IBM AT with a Hauppauge motherboard.
Okay, there you go.
Thanks. And you can see the motherboard's done, and we're probably talking about a factor of 5 speed increase, maybe even a little more over a normal AT.
Okay, so we were looking at 386. It was in your motherboard compared to this basic AT.
Correct.
Okay, now as Ken mentioned, Srini, you had a chance to pull out your card, and it's kind of neat. Let's just take a look at what your accelerator card looks like.
This is what it is, and basically you have a little card. This is what goes into the 286 socket. We have the 386SX here and the 387SX, and this goes into the 287 socket.
Right, and that's
it's actually pretty sophisticated manufacturing technology, double-sided surface mount and all that to squeeze all this in a small place. Yes.
Okay, great. Gentlemen, thank you very much. Now, if you're really on a low budget, you can't afford a new computer, you can't even afford a new board or card, there are some software solutions to speed up the performance of your computer. We'll take a look at a few in just a minute. With us in the studio now is Bruce Cheifet, president of Multisoft Corporation, and back with us again, Neil Rubenking of PC Magazine.
Neil, we've seen a number of different hardware solutions for getting speed on your computer since I first asked you the question. What are some of the other ways of doing it, some of the other types of solutions for speeding up your computer?
Well, of course, there's no way to increase the megahertz, the speed at which your computer executes instructions. But you can make it do more in a given amount of time. For example, if you're reading your hard disk a lot, why not read it once, keep it in a cache in memory, and reread from memory instead of from the disk? That's what Bruce has here.
So totally software ways.
Totally software. Or you can use smarter applications. It's possible to code an application so it'll work faster.
All right, Bruce, now you have a software program called PC Quick, I believe, which does some of the things that Neil was just talking about. What else does it do? What are the other parts of the computer that get speeded up here?
PC Quick Power Pack is a 5-in-1 product. It includes a disk accelerator, disk cache.
Right.
Secondly, a print spooler. Third, RAM disk. Fourth, a screen accelerator. And finally, a keyboard accelerator that enhances moving around on the screen.
Or explain the difference between a RAM disk and a disk cache.
A RAM disk allows you to use memory to pretend you have an additional drive. It involves the user copying things to that drive, telling the application to use the drive, and then perhaps copying things back to the real disk, because a RAM disk disappears when you turn the power off. Disk cache effectively speeds up drives that are already there so that nothing changes other than the speed.
All right, now you have PC Quick Power Pack installed, or you've treated this computer with it, and show us what it can do faster now and in what ways.
Okay, we're going to do a with and without comparison. Basically, we're going to ask this computer to do some work, creating a file, in this case 512 records of 512 bytes. That works out to 256,000 characters. It took it about 9 seconds to create the file.
Oh, it's doing it right now.
Exactly.
Okay.
Now it's going through and rewriting that file from beginning to end in sequential order, to use the technical term.
Bruce, let me ask you a question. You know, clearly we're talking about a less expensive way of getting speed here when we're using just software. On the other hand, again, there's always trade-offs. What are you trading off by using software?
Basically, it's an additive effect. If you've got a slow disk, it'll make it about the same as a fast disk. If you've got a fast disk, it'll make it faster. So instead of a trade-off, it's a matter of you start with an automobile. Do you want an added turbocharger to it to make it a higher performance computer?
And again, what kind of applications, what kinds of uses, what kind of user would benefit most from something like PC Quick as opposed to just going out and buying another chip?
Some users know that their applications are disk intensive because the red light is always blinking. Right. Databases, accounting systems, CAD programs, anything that's overlaid. When it's recalculating a spreadsheet, it's not using a disk, but just about the rest of the time it's using the disk.
Okay, Bruce, I see it's finished the task now under version A here, which is what?
Without the disk cache, it took 59 seconds to do 2 passes on that test. We'll go on and we'll add the disk cache, and it'll go right back in and do the same thing a second time.
Okay, so it was 59 seconds running the machine as is.
Right.
We're running the same tasks with your software installed.
The disk cache sets aside 90K of memory, uses that memory to make the disk appear faster, and for practical purposes, it is faster. Okay, we're on the second pass, and the combined total is a little over 19 seconds, about a 3-to-1 performance gain you can see in the bar chart under test system.
Okay, at the bottom there we see the white bar is performance without PC Quick in it, and the bottom is after you install it.
Right.
All right, Jan was talking about price. We've seen some expensive solutions before. Again, what does it cost to do something like this to your machine?
The cache alone is roughly $80. The entire 5-in-1 power pack is about $130 at list price.
Neil, quickly, we have just about 30 seconds left. What kinds of uses are really driving the need for more power? And what do you see in the future? What's going to really demand that you have power? Things Jan was talking about earlier.
Well, one of the big ones is the graphical user interfaces that are becoming more and more popular. It takes a lot of speed to get the screen to display. Oh, yes. When Microsoft Windows first came out, it was almost a joke because the processors weren't fast enough for it. That's one. Graphics processing, again, animation, I think we've probably seen TV, computer graphics. Those can come down to the desktop level if the machines are fast enough.
Right.
Yeah, voice, AI, that kind of stuff. What will that do for speed demands?
Well, voice synthesis mostly wants a lot of disk space, but if you want to do it in real time, I would assume that the speed would help there too.
Yeah. Gentlemen, we're out of time. Thanks very much for joining us. Thank you for being with us. We'll be back in just a minute with this week's Computer News.
In the random access file this week, Commodore has introduced a new, more powerful version of the Amiga aimed directly at the growing multimedia market. The new Amiga 3000 features a Motorola 68030 processor, a math coprocessor, and 8 custom chips. Commodore also showed off its new operating system, its new networking products, and its new iconic authoring system for multimedia called Amiga Vision. Amiga Vision is an object-oriented authoring system that lets you incorporate a variety of audio and visual effects and sources. The new Amiga 3000 sells for just over $3,000. Apple is responding to complaints and competitors by slashing the price of the Macintosh Portable by $1,000. You can now get the basic Mac Portable for $4,799. IBM is selling the Trackstar Plus coprocessor board that lets you run Apple IIe software on an IBM PS2. The board is manufactured by Diamond Computer System. There are new rumors that IBM will again go after the home market with a new low-end 286 PC priced somewhere between $1,000 and $2,000. The so-called home computer market is estimated to be worth about $1 billion a year. Radius Incorporated of San Jose is reporting strong demand for its new pivot display for the Macintosh. The Radius Pivot is the first computer monitor that lets you choose between landscape or portrait orientation when you reposition the monitor. A position-sensing device automatically rotates the display's pixels and reorganizes the desktop to reflect the changed orientation. In this week's Ask Dr. John video, a viewer wants to know why his printer sometimes double spaces and sometimes doesn't space at all. With the answer, here is Dr. John Heilborn.
Interestingly, your problem dates back to the early days of microcomputing. You see, in those days, one of the most popular devices for entering and printing data was a machine called a teletype. These machines automatically advanced the paper at the end of every line. In other words, you always got a line feed with every carriage return. The trouble is, today, some software supports printers that have an automatic line feed, and some do not. With those programs that require a line feed at the end of every line, your computer is not supplying it. And for those that do not require it, your computer is providing one anyway. This is what's giving you the double spacing. The key to solving this problem is reinstalling all of the printer drivers for those programs that are giving you trouble. For those that double space, set up the software for auto line feed. And for those that overprint, set it up for carriage return and a line feed at the end of every line. For the Computer Chronicles, I'm Dr. John.
NCR has introduced a single slot card that turns your PC into an ISDN terminal that can transmit voice and data simultaneously. The AT-style board works with a 286 CPU or better. It enables your PC to use an existing analog telephone. The board does the analog to digital translation. Dariana Technology has just released version 2.1 of its System Sleuth software. It's a diagnostic program which helps you solve configuration and installation problems and lets you see what's going on inside your computer so you can unravel TSR problems and memory mysteries. Taking a look at this week's top 10 software titles for the IBM PC and compatibles, PC Connection reports that QuarterDeck's Expanded Memory Manager 386 still tops the charts, followed by WordPerfect 5.1, CRAM, PC Globe, and a newcomer to the top 10, the new 6.0 version of PC Tools Deluxe. Rounding out the top 10 for the PC are Quicken, DeskView 386, Norton's Advanced Utilities, Grammatic 4, and the PC USA version of PC Globe. Finally, Computer World, the publication of the appropriately named International Data Group, is continuing its expansion into the new Eastern European computer market by announcing a new edition of Computer World for Czechoslovakia. Initial circulation is expected to be about 43,000. IDG also has magazine joint ventures going in Hungary, Yugoslavia, East Germany, and the Soviet Union. That's it for this week's Computer Chronicles. I'm Maria Gabriel.
The Computer Chronicles is made possible in part by CompuServe, which offers online information related to today's subject. Members type Go Chronicles. Non-members call for more information. Additional funding is provided by the Software Publishers Association, by PC Connection and Mac Connection, by Byte Magazine and BIX, the Byte Information Exchange, and by Intel Corporation, Personal Computer Enhancement. For a transcript of this week's Computer Chronicles, send $4 to PTV Publications, Post Office Box 701, Kent, Ohio, 44240. Please indicate program date.